All right, welcome back to Mr. Silver's Math. Today we're going to talk about graphing quadratics, specifically in vertex form. So this is just a warm-up of some vocab that we saw earlier in the week. Your vertex is the turning point or the top or the bottom of a roller coaster. We went right 3, up 1. It opens up. It's a smiley face. There is a minimum right here, so I have no graph. There's no graph that exists below 1, so my minimum is 1. Axis of symmetry is always x equals since it's a vertical line. And then your y-intercept is an ordered pair where it crosses the y-axis. And the x-intercept is where it crosses the x-axis. In this case, it does not. So make sure you write none. Don't leave it blank. If you leave it blank, Mr. Slover assumes that you just skipped it. Okay, so on day one, when we talked about vocab, there were 3 different forms. One of them was vertex form. So that's what we're going to focus on today. So you are going to create a table and you're going to generate 5 ordered pairs. Once you get those ordered pairs, you are going to graph them. So on my notes, I tried to color code what went with what. So a blue 7 went with the blue information. This is, I believe, black goes with the black one. Red goes with red, green with green. I think this was supposed to be pencil, but it looks like it turned out to be black. But I tried to color code that information. And I told you over here that you're going to plug into the equation for x. So I'm giving you your x values. I'm giving you x's 1, 2, 3, 4, and 5. I'm giving those to you. You just have to plug each one of those values into your equation. And that's the work that I have shown over here. So if x is 1, I take 1 and substitute it in where I see an x. So 1 minus 3, quantity squared, plus 3. I follow my order of operations, and I do what's in parentheses first. 1 minus 3 is negative 2. Now I need to square it, so negative 2 squared. Be careful. Negative 2 times negative 2 is positive 4. Even if your calculator says negative 4, you should know that it's a positive 4. And we have 4 plus 3, it gives us 7. And then I do similar for, now I have x equals 2. So where I see an x in this equation, so I'm using the same equation. Where I see an x, I plug in a 2. So 2 minus 3, quantity squared, plus 3. I follow the same order of operations. I do what's in parentheses first. 2 minus 3 is a negative 1. Negative 1 squared is a positive 1. 1 plus 3 gives me 4. Do the same with 3, 4, and 5. So I'm using the same equation for all of those. And I have this middle one highlighted because this is actually the vertex. So remember, the vertex is the turning point. So I'm going from 7 as a y value, 4 as a y value, 3 as a y value. Now I'm going back to 4 as a y value. So now that I changed directions, right? I was going down 7, 4, 3. I'm getting smaller. But then once I hit 3, I'm going back up larger, 4, 7. So that indicates I have a change of direction. That is my vertex. So over here, I graphed all 5 points. So 1, 7 is my ordered pair. 2, 4 is my next ordered pair. 3, 3 is my next ordered pair. 4, 4 is my next ordered pair. And then 5, 7 is my last ordered pair. I graph everything, and it looks like a U. So example 2 is the same concept. Just different equations. Here's my x values. So I'm going to take whatever these x values are, and I'm going to substitute them into the equation. So where I see an x, I plug in a negative 4. Where I see an x, I plug in a negative 5. Where I see an x, I plug in a negative 6, or a negative 7, or negative 8. And that's what all of this work is showing. And then we graph it. And then letter B, same thing. And I just plug in my information. So there's a few things that I want to talk about on letter B. So number 1, this is pointing down. The other ones have pointed up. All right, so that's a difference. It doesn't mean you did something wrong. It's just a different equation. When you plug this in, you do -2 parentheses 1 minus 3 quantity squared minus 8. Now, yes, I have been showing my work and I've been explaining that. However, you could potentially just plug this whole thing into your calculator at one time. Just make sure you plug it in exactly as written. -2 times parentheses 1 minus 3 close parentheses squared minus 8. If you plug it in differently, or if you enter it differently into your calculator, there is no guarantee that you will get the correct answer. So please take your time if you are just plugging it all into your calculator at once. That's perfectly fine. So that's the second thing I wanted to point out. The first was that this was opening down, and that's okay. The second is that we could shorten this by quite a bit by just plugging it all into our calculator. And then the third, you may have noticed I go -16, -10, -8, -10, -16. So my numbers are starting to repeat. Well, that should be happening. You have, your graph is symmetrical. So this is my vertex at 3, -8. If I were to draw in a vertical line, right where my cursor is, a vertical line, and I fold that in half on that vertical line, that would create the crease, the graph would be the exact same on both sides. It's symmetrical. Okay, so that's the beauty of these quadratics. They're symmetrical. So really, I only need to do 3 bits of work. Because if this is -16, then this is going to be -16. If this is -10, then the one on the other side is -10. Okay, this is unique to this class only. If you're working for a different math class than the one I teach, it may not necessarily be the same. So that trick may not necessarily work for you. Or there's more to that to make sure that trick does work. So today we focused on vertex form. That this is what it's called. It's called vertex form for a quadratic function.